Welcome to 60th lecture, and we have been discussing the most interesting part of DC machine, that is the armature winding. It is slightly difficult, but at the same time so interesting. That is the point I want to make. And you recall that in my last class I told there will be slots. Let us assume the number of slots 16. Each slot will house 2 coil sides belonging to 2 different coils. All coils are identical, and the coil span is this one. Okay. It is a multi-turn coil I have drawn. These are the 2 terminals, distinct terminals. This coil has got its own identity. Okay. This coil I was marking, it has got a start and finish terminals. This start terminal, this coil sides, if you start with slot number 1, that coil you call coil 1, it will be designated as start 1, finish 1. There will be a second coil which is identical. Okay. This is the coil. This is identical. This coil is identical. Only thing is its number is to be changed like this. This is second coil, start from slot number 2. I am showing it because it is displaced. Okay. It will be marked as, that is what I am telling, S2 and F2, start finish, and this is in slot number 1, this is in slot number 2. Of course, slot number 1 and slot number 2 will be close by. It is like this, it will come here. But for clarity I am showing, then what I am doing, I am connecting all of them in series. In the machine actually I am doing like this, similarly S3, F3, where in this simplified diagram it can be shown like this. Okay. This is actually start of coil 1 and finish of coil 1. Finish of coil 1 is in slot number 5 dashed. This is start of coil 2, finish of coil 2, and so on. Then you get this, but this type of winding is called lap winding. Okay? Lap winding. The reason is clear because of the fact the first coil which was here, I will just draw the by this simplified diagram. This is the first coil, it is in slot number 1. Second coil which I will draw with a diagram like this, will go like this, is not, and these are the 2 terminals of the second coil. So, this is in slot number 1, this is in slot number 2. Where this fellow is there, for this problem we have considered, this is slot number 5, 5 dashed because it is in the lower deck, this is 6 dashed. So, you see, and these coils I am connecting in them in series. Second coil is on the lap of the first coil. Similarly, third coil will be here in slot number 3. I think you have got the idea, is not it? Start finish of the third coil, that will be on the lap of the second coil. That is why it is called a lap winding. Okay. In this way, I have proceeded to complete the winding of the coils. Okay. If that be the case, that is fine as I told you, but we know that if a coil is moving, the stator field is stationary, nobody is rotating, because DC current you are passing to the coils and stator poles have become magnetized alternatively as north south like that, and their magnitude is same and they are stationary in space. Unlike say induction motor, it produces a rotating magnetic field. Therefore, to induce voltage in the rotor coils, to make it run as a generator, I must use a prime mover to run the generator. Coils will move, and I know that there will be AC voltage induced across the terminals of each coil, depending upon its position in space relative to that field. The polarity of the induced voltage will be decided, that we have discussed. Now, the question is, I want to make a DC generator, that is these voltages which are alternating in nature. With time, the polarity of this voltage across start and finish of a coil will change, reverse its polarity, AC voltage you will get. So, how to do it? Let us see that. Now, I will draw another diagram like this. Look at this diagram. Okay. Here I have shown it, the coils I have represented, it is abstract. Abstract in the sense, I know how the coils are disposed in these slots spatially. Suppose for example, S 1 F 1, this is the coil number 1. I know it starts in slot number 1, returns from its finish some slot number. I am sure about one thing, if this S 1 fellow, this coil side of this coil 1 is under north pole, the other its return will be under south pole, is not? That is what I know. Therefore, this all these 16 coils I have shown like this, they are displaced from each other by that angle 360 by 16, I make some 22.5 degree and so on. And what I have done? I have connected all the coils in series. Okay. So, I have done it like this. Finish of the, follow me very carefully, this I have shorted, because all coils have been connected in series. This is what I have done. All the 16 coils have been connected and the circuit is closed, is it? This is what I have done. Now, in the previous diagram I drew it much more simpler way, but this is a somewhat better representation to my mind. Now, what I will do is this. Remember, this conductor will be moving in a particular direction and I have taken a snapshots at a certain time, frozen everything. Then I would expect the 4 coil sides, the 4 slots will be under the influence of the north pole, next 4 slots will be under the influence of south pole and so on. Let us assume that 1, 2, these are slots number also 1, 2, 3, 4. These slots are such that the induced voltage polarity are positive. And obviously, their return they are under south pole, that is this side coil sides, this must be minus. This is how. Then the next 4 coil sides, that is S 5, S 6, S 7, A 8, direction of rotation same, but they will be suppose under south pole, has to be, if it is under north pole, S 5, S 6, S 7, S 8 must be under south pole, and the polarity of the voltage will reverse. So, it will be minus plus, minus plus, minus plus and minus plus. And similarly, then 9, 10, 11, 12 will be once again under north pole, 9, 10, other will be negative, 9, 10, 11 and 12, and this will be then once again opposite, minus plus, minus plus, minus plus and minus plus. So, I have taken a snapshot and I know this will be the induced voltage. Okay. But where is DC about it? Mind you, the magnitude of the voltage, instantaneous values, polarities are like this, may not be same with this one. Each one of them, because the value of B might change under the north pole, no doubt, but the value of B may change, is not. In fact, B distribution, let me tell, in case of DC machine, it will be like this. Somewhat trapezoidal in nature. This is the thing. This is the B distribution. Okay. So, this will be the trapezoidal B distribution, flux density distribution, BLB. Here the conductors are moving. So, the value of B here, suppose this is under south pole, this is north pole, okay, conductors are moving here relative to this field. Those who are having under south pole, they will have some polarity plus minus etcetera, but each one of them will have same polarity because they are under one pole, but the magnitude of the voltage of this coil will be different from this, no doubt. That is, this polarity of the induced voltage, although it will be plus minus for these 4 coil sides, but their magnitudes may differ, depends upon that position of the conductor and the relative value of the B there. Okay. B distribution, what is this axis? Space angle. There is no compulsion that B should be sinusoidal. In case of AC machines, we insist that B distribution let it be sinusoidal, but here my goal is to get DC. Why I unnecessarily insist upon that fact, make B distribution sinusoidal. It will be made DC in a very nice way. In fact, B distribution has to be like this, because the pole, if you draw one pole, stator pole, under this, if you suppose this is south pole, this is the center. Okay, air gap, here it will be minimum, here it will the influence of the previous north pole has ended. So, your B distribution will be somewhat like this, then flattened. Okay. Rotor structure is like this. So, here air gap is more uniform, it will be flattened and it will once again come to. So, trapezoidal B distribution, trapezoidal. But in a single coil, it goes under south north. What will be the induced voltage if you see in the oscilloscope? That will be also trapezoidal. Whatever is the nature of B distribution, that will be the induced voltage pattern. What else? Is not? So, alternating voltage will be induced, that will be trapezoidal in nature. Now, this is the crucial part now. I want to get DC voltage out of this picture. I mean, what should I do? And this, mind you, it is rotating. Time elapses. Once again, another it is right now it is 1, 2, 3, 4, 5, 6, 7, 8 will be there. After some time, the 16 coil will come this side and coil 8 will go to that side. Are you getting? This is rotating, na? I have taken a snapshot, but at any given time, this name is now not important. What I am telling, I would expect there will be 8 coils on this side and 8 coils on that side, because this fellow is rotating. Okay, this coil goes to that side, but it will be filled up by this coil coming to this side. Are you getting the point? This is most crucial. That is, at a given time, this numbering I have done fine, okay, to understand what is happening. But after some time 8 will come to this side, 7 will occupy the position of coil 8 here, 6 will advance here if it is rotating in this way, and so on. Got the point? Therefore, it looks like that in this space, these are position of this space. Suppose I say that I will, from the junctions here, I will bring out some wires. Are you getting? From all the junctions, I will bring out some wire, and this is conducting wire, this is suppose some copper strip, thick copper strip, like that. This is the most nicest part of this whole thing. Whoever first imagined this way it can be done, excellent, I mean ideas. So, you think in this way that okay, from the junctions what I will do, I will drop down some wires here and terminate it on thick copper strips, each one. Are you getting? So, it will be brought onto same distance, I mean you understand, like this. So, these are junctions of this series connected coils you have brought. And then if I say that look, what you do, you take a carbon brass, and therefore, what will happen if this fellow rotates, this junctions will also rotate in space, is not. If this coil is rotating, this can be also numbered, this fellow will also rotate, it will come after some time here, if the direction of rotation this way, this fellow will come here, like that. But I am certain about one thing. What is that thing? That you see this junction, that is this point in space, whichever coil comes, it will have a plus here. Similarly, so what I will do is this, I will connect a carbon brass here. Brass 1, and I will connect a carbon brass there in space B 2, and they will be nicely placed and they are fixed. B 1, B 2 are not rotating, B 1 and B 2 carbon brushes fixed in space. Not moving, but what it will do is this: whenever any coil side come in this position, it will touch that coil end plus, and no matter whether it is 5, 6, 7, 8 or 1, 2, 3, 4 has come this side, this polarity of this voltage will always be plus minus, no alterations. Okay. Newer and newer coils will come, this coil will go behind the scene, it will go to that side, but this will be occupied by this coil. The interesting point is, whoever comes in this position, it cannot escape this destinity of polarity of the voltage plus minus. It has to be this side plus this side minus, no matter whether coil 8 has right now here or coil 6 is there or coil 14 has come here, whoever comes, he will be treated in the same way, because BLV decides the polarity, magnitude of the voltage and polarity by right hand. Therefore, I will fish out from this series connected voltage, I will identify where is plus minus in space, and in the proper space I will connect the brushes. After some time, this copper strip will come in contact. Mind you, this because of my inability to, it is in the same position. When this coil come, it will come in touch with B 1. These junctions are moving, these brushes, carbon brushes are fixed in position, and we can conclude that no matter, let the armature rotate at high speed or whatever it is, across B 1, B 2, you will always get DC voltage, no AC business. That is, we are from the space distribution of the polarity of the EMFs, we are ascertaining, we are satisfying with arguments that whichever junction comes here, it will have plus. This one plus, oh, I am so sorry, I would connect it here. This you please forgive me. This one, this brush B 1, I will connect it here. That will be the most optimum situation. Wherever plus plus joined, you connect it here. This should be the position of B 1. B 2 is okay, minus minus, is not? Always you will get across B 1, B 2 DC, and these fellows are moving. After some time, this junction will touch, after some time this junction will come, but whenever it comes, it will have plus here. So, from the junctions you have to drop out some wires, terminated some copper strips, and placed your fixed brushes in appropriate positions and so on. Is not, then it looks like that wherever plus minus, plus minus, plus minus, this is here also I could place a brush, very nice fixed brush, say B 3, because minus minus has joined. So, this is the negative brush, this will be the positive brush. Similarly, this one will be B 3 is a negative brush, B 3 negative, it will give, and where plus plus has I will connect another brush here B 4. I can tap the voltage from these positions, And then what I will do is this is also plus. So, have you got the idea? This is the essence of the thing. You have AC voltage fundamentally induced in each coil, no doubt, and it will be alternating in nature, because B distribution is alternating, although not sinusoidally, it does not matter. It is trapezoidally, it is varying. Therefore, I will get AC voltage induced across each coil. Here if you see the voltage waveform between these two terminals, that will be AC in the oscilloscope, and that will be trapezoidal alternating. See the voltage between these 2 points, it will be AC. Only thing, this voltage and this voltage will have a phase displacement, because they are not put, they will not be in phase, their positions are different in space. But the interesting point is, I want to get a DC voltage out of this AC voltage environment. Then it is done like this. Argument is, imagine that it is rotating at high velocity like that, fine. There are suppose 16 coils. So, at a given time I will expect 4 starting coil sites will be under north pole, say 1, 2, 3, 4, S 1, S 2, S 3, S 4 under the influence of north pole, and its return coil site must be, that is F 1, F 2, F 3, F 4 finish coil sites will be under the influence of the south pole. And suppose direction of rotation is such, then by applying right hand rule I come across this polarity plus minus, plus minus, plus minus for these 4 coils. If S 1, S 2, S 3, S 4 under the influence of the north pole, I take a snapshot at that time, then S 5, S 6, S 7, S 8 should be under the influence of south pole, and their return or finish coil sites F 5, F 6, F 7, F 8 should be under the influence of north pole, and that way I decide the instantaneous polarity of the induced voltage, how in space it is distributed, because each coil has got 2 terminals. Then I argue that okay, let the rotor rotate, but okay, at a given time it is expected not that 1, 2, 3, 4, S 1, S 2, S 3, S 4 will remain always under north pole, it is moving. S 1, S 2, S 3, S 4, suppose it is moving in the clockwise direction, it will move this way, but next S terminals will come another 4 and their distribution of polarity will be exactly same when they occupy the positions of S 1, S 2, S 3 and S 4, which was occupied earlier, a bit earlier by those 4 coil sites. Therefore, in space the polarities of the voltages remain same. Therefore, we now know what to do to tap a DC voltage out of this AC distribution of induced EMF is that wherever plus joins drop from all the junctions you drop conductors and terminated thick copper strips. Okay. Then place some carbon brass in space which will not move. Mind you, these junctions will move, because they are at these junctions, this fellow is moving, but this brass I will not allow to move with some spring, this type of arrangement, stator structure, I will hold it in this position always. Similarly, B 2 negative negative, B 3 negative negative and B 4 positive positive. Then I will say that okay, across B 1 B 2 you get a DC voltage, and I will go further. I will join this positive positive by an external wire. These are all stationary, and I will join this negative negative together, and this I will say ultimately as my armature terminal A 1, and this negative negative I will say as armature terminal A 2. Okay, we will continue with this in this next time. Very interesting. I mean, how really from AC voltage you get the DC voltage. Thank you.